Alright class, welcome to Math 2010. This is our lesson for today. We're continuing on from last time in our Unit 1 homework. And we have just where we left off with our representation of these chip charts. Okay, so these little dots. And we have 453. Okay. So each of the columns, yellow is the ones place, the blue is the tens place, and the green is the hundreds place. Okay? So each one of those is a bundle of 10. Okay? So I take 10 ones, bundle it together, and get 1 10. If I happen to have enough objects to have many tens, or 10 tens at least, then I can bundle 10 of those tens together to get 100, and so on. A bundle of 10 100s gives you 1,000. Okay? But now that's how we normally count. Okay? And what I'm showing you is the concrete way to arrange things. Okay? Okay, now when I count concretely, which means manipulatives or things that move around with your hands, like these dots here, that means I can do a certain everything mathematically at a basic level. Okay, so you'll start with very early elementary students to count and do math at the basic level. Okay, so you'll have them learn place value. They do know, a lot of them come into kindergarten knowing numbers already and the number names, but how the structure works is a little bit different. Okay, so I have 1, I can count in base 10, so 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so I have 10 objects in this first column, in this first place. I have number names for each of the numbers. Until we get to 10 is when we have a new numeral. Okay? And so when we do that, we write the 1 in the tens place, okay? Which means I'm taking all of these and I'm going to bundle them together, and they're going to be one set of 10 objects. Okay? So you can think about that as one set of 10 objects. Okay? So that's what base 10 means. Once I get to 10 objects in one place, then I bundle them together and put the new numeral for 1 in the next place to the left. Okay? So we have one group of 10 objects, and they're bundled together. The next level of abstraction is called pictorial. Now, once your students are familiar with base 10, with their hands-on objects or manipulatives, then they can start drawing representations of the base 10 system. Okay, and we'll go ahead and do that with our chart. Okay, so we have a red column. We have a green column. Oops, let me get those back here. I wanted to use black here. And we have a blue column. And we have a yellow column. Okay. Now we use colors here because we want to have a variety of bases, a variety of ways. So not all of the places are going to be the same. So yellow is the first place on the most right, then blue, then green, and red. Okay, and base 10 means that I'm going to draw 10 objects here. Five, 6, 7, 8, 9, 10. And when I get to 10 objects, I will group them together, and I can put them over into the blue column. Okay, so there's an object there. I can keep adding more. Okay, and then when you have this total objects, you can name the number using abstract numerals. Okay, so there's 1, 10, and 3 ones left over. Okay. So that's the pictorial version. Okay. So you can kind of see how with the manipulatives and the dots on paper, how you can move them around with your hands, and then and that will naturally get you to be able to draw them because it's faster to draw than to cut out and move things around with your hands. Now, this is the second level of abstraction that we look at mathematics. We can look at a third level of abstraction, which is what we normally do as adults, and as when students get into higher grades. Okay, and that's what I did here. Was I said a 1 and a 3. Okay, they're next to each other. That means one group of 10, 3 leftovers. Okay, when I'm working with base 10. Okay, so then counting as a review for abstract, we have counting numbers. These symbols are abstract because there's a lot that goes into a 1, a 2, a 3, 4, and 5. Okay, 5 objects. Okay, so I have the spread of 5 objects, for example, and I can represent that spread of objects with one numeral. Okay, 6, 7, 8, 9, and then 10. Okay, we only have in base 10 we only have 10 symbols. Okay, here's all the 10 symbols: 1, 2, 3, 5, 6, 7, 8, 9, 10. Okay, there's only 10 symbols in this base. When we get to the 11th symbol, which is the 10th number, notice that this is 0 leftovers and 1 10. Okay, a group of 10. Okay, I'm bundling them together. Group of 10 leftovers. Okay. Now, concrete, pictorial, abstract. Those are 3 levels that we'd like to look at math with. We might not have time to do that with every concept, but I want to show you as a start how it will work. All right, class. What we're going to do now is we're going to take our concrete object here, and we're going to do a different base. Okay, so we're going to change bases from base 10 to base 5. Okay, base 5 means I'm going to go ahead and count. Base 5 is the same structure. Now we're looking for structure. This is a great mathematical practice. 1, 2, 3, 4, 5. I put 5 objects in here, and that's when I stop, because in base 5 you have 5 objects, and once you get that into the leftovers, the ones place, you bundle them together. Okay, you bundle them together into one object that represents 5. Okay, you put that into the next place, and you keep counting. So that's 1, 1, 1 base 5. And so that's how we're going to name these numbers here. 1, 2 base 5. So it's not 12, because 12 is a base 10 number, so we have to do 1, 3 base 5. 1, 4 base 5. 1, 5 base 5. Now 1, 5 base 5 doesn't make sense, because every time we get 5 objects, we have to bundle it to another bundle of 5. So we bundle those together, put them into the next place, and we have 2, 0 base 5. Okay, let's count some more. 2, 1 base 5. 2, 2 base 5. 2, 3 base 5. 2, 4 base 5. And 2, 5 base 5. Okay, once we get to 2, 5, we have to bundle them together. So there's not really a 2, 5 base 5. There's only 3, 0 base 5. Okay, so that's the concrete way about how base 5 works. Let's go ahead to do pictorial. Okay, pictorial representation for base 5. So I'm going to go ahead and draw in some dots here. We have 1 in base 5, 2, 3, 4, and 5. Okay, so I'm going to go ahead and draw them out. And then a bundle, representation of bundle is circling and then putting an arrow over and putting a new dot. Okay, so those are, once I get to 5 objects in the yellow column or the leftovers, then we bundle them together and put 1 in the blue column, okay, which is base 5. So let's go ahead and keep track of what these places are. And I'm going to erase a couple dots here to help us, and put those back down here. Okay. Now in base 5, we still have the leftovers in this column here. Okay, they're still like the ones place. Okay, ones. Now, in base 10, this is like 10 to the 0 power, right? Equals 1. But we're in base 5 now, so we're going to change our 10s to 5s. 5 to the 0 power still equals 1. Okay. In the base 10, the next place over here is 10 to the first power, or groups of 10. Okay. But since we're working with base 5, we're going to say that that is 5 to the 1, which is equal to 5s. Okay. So this is the 5s place. 5 to the 1 is 5, and then we're going to call that the 5s place. Okay, so this gets a little bit tricky. But all of these objects in here, there's one object here, that is a group of 5. Okay. Now, just with base 10, this is the hundreds place, right? Or 10 squared. Okay. So I'm looking at powers of these base numbers. But since we're working at base 5, that's going to be 5 squared. And 5 squared is 25. So this is actually the 25s place. Okay. If we want to write it in base 10 to help us understand what's going on. And the pattern continues. This one is 5 cubed, which is equal to 125. And so these are the 125s place. Okay, because every object in this group is worth 125, base 10. Okay. So to get an idea how this works. Now what we're going to do is we're going to count in base 5. So that was counting with concrete and pictorial. Now we're going to count in base 5 with abstract. Okay. So we start with 0, 1, 2, 3, 4, and 5. Remember, when we get to 5 objects, we cannot have 5 objects because it's automatically bundled together. Okay, so I'm going to cross out the 5. Whoops, let me do green here. Cross out the 5, and I'm going to get another number. Okay. Remember that there's 5 objects here. We have to bundle them. 5 objects here. We have to bundle them and make 1 object here. So we bundle them so that there's no leftovers, and there's 1 object in the 5's place. Okay. So that we have 10. And then we keep going. If we add another to this place, another object, that becomes 1, 1, base 5. 1, 2, base 5, and so on. 1, 3, base 5. 1, 4, base 5. 1, 5, base 5 cannot happen, so I'm going to cross that out, that 5 right there, and then I have the next number as 2, 0, base 5. 2, 1, base 5. 2, 2, base 5, 2, 3, base 5, 2, 4, base 5, 2, 5, base 5. Now 2, 5, base 5 doesn't count. Okay, so we cross that out, and we get 3, 0, base 5. And that goes on until we get, let's go ahead and do up until we get to 4, 3, base 5, 4, 4, base 5, and 4, 5, base 5. Now 4, 5, base 5 doesn't work because this 5 here, again, it needs to go to a 0. It will bundle and go to the next place. Now I'm going to increase the next place, which is the 5's place, and to be 5, 0. Oops, let's go back here. To be 5, 0, base 5. Now this place right here also has a 5 in it, which we cannot have. Okay, so we cross out that 5, and we put in no leftovers, and then 1 more on the hundreds place, or the 25's place, and there's no leftovers and there's none in the 5's place, or there's none in the leftovers. Okay, so that after 44 base 5 is 100 base 5, or I can't say 100 because that's a base 10 number. So 100 base 5. Okay. And then you keep going. 101 base 5. 102 base 5. And so on. Okay. So that's a little bit more abstract counting in base 5. So that's why I introduced it in a concrete way. So you can see the pieces bundle themselves. Abstract with a drawing, and then pictorial with a drawing, and then abstract with just numerals. Okay. So that's base 5. Let's go ahead and have you do an example here of looking at something in base 5. On your chip chart, we want you to show 214 base 5. Now, in order to distinguish the numbers between base 10 or base 5, base 10 numbers we have not written with any sort of indication that they're base 10. We assume them that they are base 10 if there's no other indication that there is base 10, that they're different base. Traditionally, also in the textbook, they will put a little 5 subscript next to the number in parentheses to show you what base they're talking about. Okay, and notice that once we got to 5, all of the 5s bundled, and this one up here and this one up here, they bundled into numbers and then higher place values. And so there is no number in base 5 that is higher than 4. Okay, they can't have any 5s or 6s or 7s or 8s. So you can tell a number is by its base a little bit by how many numerals there are allowed. Okay, so in this example, I have 214, 214 base 5. And so the 2 and the 1 and the 4 are all legit base 5 numbers because they're not 5 or greater, or they're not bigger than 4. Okay, so we're going to show it on our chip value, or chip chart. So I'm going to do my red column, my green column, my blue column, and my yellow column. 214. So there are 2, and the places are all the same as base 10, but they just have different values. Okay, so showing 214 base 5 on your chip chart shouldn't be too hard. Okay, because we have 2 green objects here, we have 1 blue object, and we have 4 yellow objects. Okay, so that's 214 base 5. And you show it on our chip chart. We need to explain that again, that each object in here is a leftover. Those are leftovers. This one is a bundle of 5. These 2 objects here are bundles of 25. Or 5 squared. Remember, this is 5 to the first, this is 5 to the 0. Okay. And there was no red objects. I didn't have any places over here where there is bundles of 125, okay, or 5 to the third. So I'll put 5 to the third here, just as a reminder. All right. Okay, so that's base 5. Okay, class, we're going to do a video about a new base number. So we've seen base 10 and we've seen base 5. So let's do base 3. Okay. Now base 3 means that as I count in my ones column, my leftovers, 1, 2, and 3. Okay, once I get to 3 objects, and that's my base, I'm going to bundle them together and put them into the next place over to the left. Okay, bundles of 3. Okay, and I'm going to keep counting. This is 3, 0, now 3, 1, base 3. Or sorry, 1, this is 1, 0, 1, 1, base 3, 1, 2, base 3, 1, 3, base 3. Now this comes over here, bundles into another bundle of 3, and I got 2, 0, base 3, 2, 1, base 3, 2, 2, base 3, and 2, 3, base 3. Those 3 bundle, and I got 3, 0, base 3. Okay. So I was hoping that you guys are getting the pattern, looking for the structure, okay, and repeated reasoning, okay, look for the patterns in the concrete way to express different bases. All right, class, we have the pictorial level of base 3. Okay, the setup is leftovers again. We have 3 to the 0 power, anything with 1. Okay, we're going to see how much it takes to make the next place. So this is the 3 to the 1, which is the 3. So we have the 3's place here. Let's see how much it takes to get to this place. 3 squared is equal to 9. So this is the 9's place. And then we're going to do the last one in the red column. We have 3 to the third, which is equal to 27. So this is the 27's place. Okay. So as we count in base 3 with this pictorial version, we're going to put 1 base 3, 2 base 3, 3 base 3. I'm going to bundle them together, put them over to the next column, and have one group of 3 here. 1, 1 base 3, 1, 2 base 3, 1, 3 base 3. Now this 3 goes over to here, and we have another one here. 2, 0 base 3, 2, 1 base 3, 2, 2 base 3, 2, 3 base 3. Now 2, 3 base 3 doesn't really exist, so we bundle those together, and we go down to here for another one. Now in the blue column, the 3's column, I have 3 objects, so they cannot stay that way. They must be bundled together, and then they go into 3 groups of 3, which is 1 group of 9. Okay, so we have that, and that's how our base 3 is working. So we can see more of the bundling and the moving to the columns with a smaller base. Okay, so let's go abstract, and we're going to count 0 base 3, 1 base 3, 2 base 3, 3 base 3. Well, 3 base 3 doesn't work, right? We'll bundle those together, and we get to 1 bundle of 3, no leftovers. Okay, 1, 1 base 3, 1, 2 base 3, 1, 3 base 3. Now 1, 3 base 3 doesn't work. You take that 3, we're going to bundle it together, put it to the next place, and we have 2, oops, go back to here, and we transform this number into 2, 0 base 3, 2, 1 base 3, 2, 2 base 3, 2, 3 base 3. Well, 2, 3 base 3 doesn't work. We're going to cross that 3 out, put it over to the next place by doing 3, 0 base 3. Now that one number doesn't work either because we have 3 in our 3's place, so we cross that out. And our new number is 1 in the 9's place, no 3's, groups of 3, and no leftovers. So we have 1, 0, 0 base 3. And we keep counting 1, 0, 1 base 3, 1, 0, 2 base 3, okay, 1, 1, 0 base 3, 1, 1, 1 base 3, 1, 1, 2 base 3, 1, 1, 3 base 3. Well, that doesn't work. So I'm going to back up, and I say that that's going to be 1, 2, 0 base 3, 1, 2, 1 base 3, 1, 2, 2 base 3. Okay, 1, 2, 3 base 3. Well, that doesn't work either. So we got to make this one a 3, 0 base 3. Well, that 3 doesn't work either because that 3 will also bundle. And we have 2, 0, 0 base 3. Okay, 2, 0, 1 base 3, and so on. What I've done here is I've counted a certain number of numbers in base 3. We have the 0 I'm going to count as 1, number, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I've got 20 numbers in base 3 that I've counted up. Okay, so part of the homework will have you count to a certain level in base whatever and count that many numbers. Okay, so that's how base 3 works. Now let's go ahead and do an exercise with it. Okay. We're going to do showing on our, we want to show 2011 base 3 on our chip chart. Okay, it's kind of neat to say that because it's an alliteration, right? Red, green, blue, and yellow. Okay, 2011 base 3. So we're going to use dots with this one. Okay, so 2011. So we can even start with the yellow group and going from right to left, even though we read the other way. We can do 1 dot there for yellow, 1 dot for blue, no dots for green, and 2 dots for red. Okay, 2011 base 3. That's how we show it on a chip chart. All right, class, we have one more base to talk about. Base 5 and base 3 were lower than base 10, but things get a little bit different when we get a base that's higher than base 10, like base 12, for example. And so here is a concrete way of how base 12 will work. 1 base 12, 2 base 12, 3 base 12, 4, 5 base 12, 6 base 12, 7 base 12, 8 base 12. Okay. Remember, when I get to 12 objects in this leftovers column, that's when I bundle. Okay. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 base 12, 10 base 12, 11 base 12, and 12 base 12. Now I got to 12 objects here, so I'm going to bundle them up, okay, and I put them over here into the 12s, this next column over here, which is going to be the 12s column, right? Okay, so we have 1 base 12, 1 2 base 12, 1 3 base 12, 1 4 base 12, 1 5 base 12, 1 6 base 12, 1 7 base 12, 1 8 base 12. Got two more little dots here. Okay, and so that's all the dots I have prepared, but we'll go ahead and go to the pictorial level to see how this will work. So that's concrete level for base 12. Okay, pictorial and abstract versions of investigation of base 12. Okay, so in base 12, we have 12 objects that we put into each column and to each place, and when we get to that high, we bundle them together and put another one in the place to the left. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 objects. Okay, so we bundle those together and we put them over here. Okay, now it'll take a lot longer to populate this blue column, okay, with groups of 12 compared to when we did threes. Okay, so we have 1 1 base 12, 1 2 base 12, 1 3 base 12, 1 4 base 12, 1 5 base 12, 1 6 base 12, 1 7 base 12, 1 8 base 12, 1 9 base 12, 1 10 base 12, 1 11 base 12, 1 12 base 12. So there's no 1 12 base 12. That's actually the same as 2 0 base 12. Okay, so you guys get the idea, I'm hoping, and that this is the leftovers. So 12, to see the value of these leftovers, to see how many go into each bundle, 12 to 0 is 1, so those are singles. Looking for the pattern in powers of 12. 12 to the first is equal to 12, and that's the 12th place. 12 squared is equal to 144, okay? Because 12 squared is bundles of 12, 12 bundles of 12. And so that's going to be the 144's place. And then 12 to the third is equal to 1728, I believe. And that's going to be the 1728's place, okay? So in the abstract way to count in base 12, we start with 0, of course. 0, 1, 2, 3 base 12, 4 base 12, 5 base 12, 6 base 12, 7 base 12, 8 base 12, 9 base 12, 10 base 12. Now this right here is 10, which means one group of 12 and no leftovers. Okay, but we don't have 12 objects listed yet. And so that's what's tricky about base is bigger than 10, because we need more than 10 symbols. Notice that all we have in our regular everyday life is just 10 symbols for these numbers. Okay, so textbooks traditionally use a T for 10 and an E for 11. In bases higher than 12, like base 16 is something that people have used a lot. They'll use letters A, B, C, D, E for numbers that are higher than 10 and that higher base. Okay, so once we have 12 symbols here, okay, so we count the symbols again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 symbols. We are okay to, after we have 12 dots right here, just like we have 12 dots right here, we bundle them together and we put one group of 12 with no leftovers. Okay, so this 10 means 1 0 base 12. One group of 12, no leftovers. Okay, that's what we want you to get out of all of this place value. That the symbol for 10 is one group of the base and no leftovers. Okay, so as we continue on, that's 10, 1 1 base 12, 1 2 base 12, 1 3 base 12, 1 4 base 12, 1 5 base 12, 1 6 base 12, 1 7 base 12, 1 8 base 12, 1 9 base 12, and I don't go to 20 next, no. I need to do more objects into the ones place, the leftovers, to get to 12 objects. So we go 1 T base 12, 1 E base 12, so I have 12 objects now, and now I can go to the 2 0. Okay, 2 1 base 12, 2 2 base 12, 2 3 base 12, 2 4 base 12, 2 5 base 12, 2 6 base 12, 2 7 base 12, 2 8 base 12, 2 9 base 12, not to 30 yet, but 2 T base 12, 2 E base 12, and then we get to 3 0 base 12. Okay, We'll go ahead and skip ahead, and we have, let's skip ahead to 9 base 12. 9 base 12. After that, it's not 100, but 9t base 12, because I need 12 objects in the ones place before I can bundle. 9t base 12, 9e base 12, and then I have 100, right? Well, no, because this value placed right here has to also go up to 12 objects. Okay, so that's going to be t0 base 12, t1 base 12, t2 base 12, t3 base 12, okay, and so on. So on to t9 base 12, tt base 12, te base 12, and then we have e0 base 12. Okay, 11 objects in this column, 0 leftovers, e1 base 12, and so on. After we get to e9 base 12, we have et base 12, then we have ee base 12, and then we can go to increasing this one to another one to go to 0, increasing that one to e, from e, 11 objects, into now 12 objects, which you bundle to put to the 0 leftovers and to put one to this next place over to the right, which is the 144th place. So I have 12 bases, 12 objects in this column of 12 bundles of 12, and that becomes 144, one group of 144. Okay, and so you go to 101 base 12 and so on. 102 base 12. Okay, and that's how base 12 works abstractly. Okay, so let's go ahead and do an example here. We want to show 1E4 base 12 on your chip chart. Okay, so I'm going to draw up my chip chart. Red, green, that's a funny looking G. Okay, blue, yellow. Okay, so for 1E4, I'm going to start with the yellows. There's 4 yellows. For blue, there are 11 blues. Okay, so I can go ahead and just put a bunch of dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 blues. And for green, there are one green. Okay, so that's how you do 1E4 base 12 on your chip chart. Okay, class, we're going to do conversions now. We need to convert between these numbers of different bases. Okay, conversions is a great way to help you look for structure. So you're going to make your students do mathematics where they look for structure and they look for patterns, and so this is one way that we can have you do that. And you might not necessarily do this with your elementary students, but it's going to be beneficial for this class and your facility with base 10 place value. Okay, so we want to convert. So for our first example, we're going to convert 1 to base 3 to base 10. Okay. And what does it mean? To convert to base 10, we have to look at the numbers in this right here. Okay. What does that number mean? What does that number mean? Remember, the first place on the right, going from right to left, is the leftovers. Okay. Anything to the 0 power. Okay, which is just the ones place. Okay, so it's always going to be called the ones place no matter what base you're in. Okay, this one is going to be groups of 3 because they have the next place to the right is the groups of the base, groups of 3, or the 3's place. Okay, so if you have one group of 3, and 2 leftovers, we will go to mathematics to help us understand this. We will get into multiplication here in a little bit, Unit 3, but one group of 3 means multiplication, 1 times 3. And is plus, and then 2 is leftovers. Okay, so that's the same as this, which is the same as 3 plus 2, which is equal to 5. Now if you analyze the numbers with the I of base 10, you can convert any base into base 10. Okay, So I'm not going to write a subscript on 5 because it's just base 10, but this is my answer. Okay, let's go ahead and do another one. So you see how this works. We're going to convert 714 base 9 to base 10. Okay. If you think you know how to do this already from my first example, go ahead and pause the video and try it out and see if you can convert this number to base 10. And then play the video and you'll be able to see if you are right. Okay, so analyzing the number by place value, leftovers. This one right here are groups of 9, the 9's place. This one right here is groups of 9 squared, or 80 for 1's place. Okay, so let's go ahead and analyze the amount in each group, of each group in each place. Okay, so we have 7 times 81, adding on 1 times 9, leftovers 4. Okay, so that's going to equal to 7 times 81. Now I don't know of that offhand, but maybe I can figure it out. 7 groups of 81, so I have 7 groups of 80 and 7 groups of 1. So 7 groups of 80 is 560, and 7 groups of 1 is 7, so we have 567. And this kind of mental math you'll learn later on when we get to multiplication. And plus 9 plus 4. And that's going to equal 580. So I have 560 plus 9, 567 plus 9 is 576, plus 4 is 580. So double checking that. Okay, so there's that one. 580 base 10. Okay, so let's do another example. What do we have here? We're going to convert a number higher than base 10, like the base 12, to T5 base 12 to base 10. Okay, so analyzing each of the places by value. Okay, so that's leftovers, or the 1's place. The T is going to be the 12's place. 12 to the first power. 12 squared is 144, so we have 144's place. And 12 to the third, we found out, was 1728, so this is the 1728's place. Okay, so I have 2 groups of 1728. I have E groups, or 11 groups of 144. I have 10 groups of 12. And I have 5 leftovers. Okay, so you want to break those down into that way. Now the E becomes 11 here, so that's E. And then 10, T was 10, right? So we're going to use base 10, so we'll convert those to base 10. Now 2 times 1728 is 3456, or 3,456. 11 times 144 is 1584. 10 times 12 is 120, and 5. So we add all those together, and we get 5,165. Okay. So in this class, you want to use mental math as much as you can, but if you get stuck like this, these big numbers, early on, it's okay to use a calculator. We're going to go ahead and use mental math strategies for addition, subtraction, multiplication as the units go on. Okay, we're going to do some more conversions this time. And last time we were converting numbers into base 10, from another base into base 10. And so we need to go back the other way and convert numbers that are in base 10 already to another base. Our first example is converting 14 into a number in base 3. So what we're going to do is we're going to use our chip chart to do a pictorial representation of this conversion. Okay, so I'm going to start by going to my chip chart for red, then green, then blue, then yellow. Okay. So 14 means that I put 14 dots here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I put 14 dots into my first column. That's my leftovers column, and I'm going to convert to base 3, which means I'm going to organize them according to the base 3 structure, which means every 3 dots that are in my yellow column, I'm going to group them together, and they go into the blue column for blue dots. Okay, so we did that, that, and that. Okay. So the dots in the blue column are groups of 3. So I have 4 groups of 3. And then there's 2 leftovers here, which I don't do anything with because they're not groups of 3, so we'll have to leave those there. And I'm going to go ahead and group any groups of 3 in the blue column. I'm going to put them into this green column, which are the 3 groups of 3, or 9s. Okay. So I have one of those. And to convert them into a different base, I take a look at that this is 1 of the groups of 3, and that's 1 of the groups of 9. And so we have 1 of those groups, 1 of those groups, and 2 of those leftovers. Okay. So it's 1, 1, 2, base 3. Okay. So 14 is 1, 1, 2, base 3. Now this is the pictorial way, and I'm going to go ahead and try a different one to show you. In example 2, let's go ahead and convert 89 into a number in base 7. Okay. So converting 89 to base number in base 7. Now, am I going to draw my chip chart, red, green, blue, yellow, and put 89 dots in the yellow spot and then start organizing them by into group 7? No, I don't think so, because that's going to be more tedious. Okay? We need a faster way. And so that's why we have this third level of abstraction into abstract thinking to help us handle very large cases. Okay? And so that's very useful. Now, looking at what 89 is, if I have 89 dots and I want to convert them to base 7, I have to look at what structure of the numbers are in base 7, or the places, the value of each place. Okay, so I'm going to do place values. Now the place values in base 7 start with the ones place, which is 7 to the 0 power. Right, so that's the ones place. And I will increase by groups of 7 as I go to the places to the left. So we have 7 to the first power is 7s. 7 to the second power is 49s. And I'm going to keep doing this until I notice that the number that is the place value is larger than the number I'm converting. Okay? So 7 to the third power is equal to 343. 343's place. Notice that I'm there. This number right here, 343, is larger than 89. Okay? So I'm over my number here, which is good. That means that there's at least one group of 49. There's at least one group of 49 in 89. Now, you use division, the power of division, to help us know how many groups of 89 are in there. Or groups of 49 are in 89. So I'm going to go ahead and do this work down here. 89 divided by 49. Now I know that there's going to be one group of 49 in there because 49 times 2 is just 98. It's too big. Okay, so I subtract that and I get 40 for my leftovers there. I'm going to have one group of 89. So I'm going to label that right here. Oops, one group of 49, sorry. So there's the 49's place. Okay. This, what we have, the 40 is now leftovers to distribute among the other places. So notice that there's the group of 49's we've taken care of. Now we need to take care of the groups of 7. How many groups of 7 are in this? Are in the 40? Okay, well, we use division to help us. 40 divided by 7 is 7 times 5 is 35. And when I subtract 35 from 40, I get 5 as leftovers. Okay, so this is my groups of 5, or 7s. And notice that this is the base number. When I get down to dividing the base number itself, these are going to be just the leftovers, and we don't need to divide anymore. Okay, and so when we do that, our number is going to be 1 groups of 49. The next place is 7s, so we have 5 groups of that, and 5 leftovers. So 89 into a number base 7 is 155 base 7. Okay. Let's do another example. In example number 3, we will do convert 645 into a number in base 5. So let's think of the places. Our first place value is 5 to the 0, equal to the 1's place. 5 to the first is equal to 5's place. 5 squared is equal to the 25's place. 5 to the third is equal to the 125's place. Okay, so I got to get to 645. So 5 to the fourth is equal to 625's place. Oops. Okay, 625 is still not big enough, so we do 5 to the fifth, which is equal to 3125. So multiplying 625 by 5 gives me 3125's place. Okay, notice that I can stop here because the 3125 is larger than the 645. Okay, so I have over the number here. This one right here is there's at least one group of 625 in this number. We'll see how many groups there are. We'll take our 645 divided by 625. And when I do that, I know that there's one group of 625 in there. Subtract that off and I get 20 leftovers. Okay, now this 20 leftovers is all I got. We're going to label what we found here. So there's one of groups of 625. Okay. Now there's 20 leftovers, but the next place after 625's place is 125's place. So I have to see how many 125's there are. Well, there are no 125's there in that number. Oops. Okay, and then we go to the next place, 25's. Well, this number is still smaller than 25, so we actually have no 25's as well. And then we go to the next number, the 5's place. We do have 20 is more than 5, so let's do this one. Let's see how many 5's there are. 5. Oops. To do that, we do 20 divided by 5, which you know is 4. When we subtract off the 20 there, we get 0. Let's see what we got here. We have 4 5's, so that's in the 5's place. There's 4 of those. And then once we have our base number here, we can stop, and then this is the leftovers. Okay. And so what our number will be is we have, oops, we ran out of room here, so let's go down here. We have one of the 625's. No 125's, no 25's. So no 125's, no 25's. We have 4 5's, and then 0 leftovers. And that's they're 1 0 0 4 0 base 5. So that's what 645 is in base 5. Okay. This example number 4, I'm going to go ahead and check what I did up here with using the abstract way. Convert 14 into a number in base 3. Okay. Okay, and if you know how to do this already, go ahead and pause the video and go ahead and try it out to verify what the answer is using the abstract method. And then resume when you're done. Okay, moving on, we have the places of the 3. Now up here in this one, we didn't write down the places here, so let's write them down here. So what places do we have? We have 3 to the 0, which is the 1's. 3 to the first, which is the 3's, 3 squared, which is the 9's. Now 9 is still not big enough to go over 14, so I'm checking here and here. Gotta keep going. 3 to the third is equal to 27. So we have 27s. Now notice that the 27 space is the over the number. Okay, so we have at least one group of 9. In this. So let's go ahead and check how many we have. So we take our 14, divide by 9. There's 1 there. 14 minus 9 is equal to 5. So I have 5 left to distribute among the rest of the places. We have the 3's and then the leftovers. Okay, so the next place down is 3. So we're going to do 5 divided by 3. So we subtract our 3 there. 5 minus 3 is 2. And so what we have is the base number here. Let's go ahead and label what we've done here. Okay, that's the group of 9's. This is the group of the 3's. This is my base number. Once we reach our base number here, we can go ahead and stop looking for divisions, and this is going to be our leftovers. Okay, so what do we have as our number? We have 1 9's, 1 3's, and 2 leftovers in base 3. Okay, so let's go ahead and check that with our top number, and surely enough, we have 112 base 3. Okay, so as an example for you to try. Let's go ahead and do a harder example, example 5. We want to convert, it's our last example, convert 462 to a number in base 12. Okay, go ahead and pause the video again. Try out the problem and see if you got the right answer. Okay, let's go ahead and do this one. So the places that we need to worry about are 12 to the 0, which is the 1's place, 12 to the 1, which is the 12's place, 12 squared, which is the 144's place. Okay, so checking my number here, 462, 144, still got to go higher. 12 to the third, which is 144 times 12. I get 1728 again. And that's over the number here. So that means there's at least one group of 144 in my number. Okay. Oops. So I'm going to take my number 462, divide it by 144 to see how many groups of 144 are in there. And doing some estimation, we'll do 3 of them, and we get 432. Now when we do subtraction, we get a difference of 30. Okay. And we're going to go, that was the, this one right here was the 144's place. Okay, and then we got to go to the next place down, which is the 12's place. So with our leftovers is 30, that's still bigger than 12, so we will have some 12's in there. And so we do 30 divided by 12, and we know that goes in twice, the difference of 24 there. And with the product of 24, the difference is going to be 6. Okay, so let's analyze what we got here. This is the 12's place. And then this right here, since we're at the base number here, we have 6 as our leftovers. And that means that we're done with our numbers. So let's go ahead and we got all the places. We got 3. So our answer is going to be 326 base 12. So 326 base 12. All right, so that's our lesson for conversions.